all games have multiple Nash equilibrium, you don't have to worry. Here's another game where it shows two people, Utkarsh who makes puris and Pradeep who also make puris, independently deciding on the number of puris that they are going to make. So, the numbers are given in red are 0, 3 and 4.5. Now, don't get worried about these numbers again. You can multiply them by say 100 and you will get 0, 300 and 450. Instead, look at the payoffs which are given inside the different cells. So, just like before, if Pradeep makes 0 puris and Utkarsh also makes 0 puris, then they both have a payoff of 0. If Pradeep makes none and Utkarsh makes 3, then of course Utkarsh is like the monopolist of puris, so he gets 18 while Pradeep gets 0. On the other hand, if he makes even more puris, 4.5, and Pradeep makes none, then his payoffs increase to 20.25. So, let us look for Nash equilibrium in this particular game. What we can simply do is investigate each cell at a time. 0, 0, it seems quite obvious, could never be a Nash equilibrium. Let us try the next cell, 0, 3. Could this be a Nash equilibrium? No again, because if Pradeep was making 0, then Utkarsh would rather make 3. So, that is not a Nash equilibrium. How about 0 and 4.5? Can that be a Nash equilibrium then? Well, if Pradeep makes 0, then Utkarsh obviously would like to stay on at 4.5. But if Utkarsh makes 4.5, then Pradeep would rather be at 3 because that gives him his highest payoff. So, then again 0 and 4.5 is not a Nash equilibrium. And you can continue in this fashion, but let us zero into the situation where both of them make 3 puris each, which gives you a payoff of 9 and 9. Could this be a Nash equilibrium? Let us check. If Utkarsh were to make 3 puris, how many would Pradeep want to do? Well, between 0, 9 and 6.75, 9 is obviously the best. So, Utkarsh would also stick to 3 puris. Also, if Pradeep makes 3 puris, then we can show that Utkarsh would also make 3 puris. So, 3, 3 is a Nash equilibrium, because if the two people Utkarsh and Pradeep were to find themselves make 3 puris each, then they would like to stay with those strategies. So, this is a situation where there is only one Nash equilibrium. And given the particular game that we have described, you might think that this is really some form of a Cournot equilibrium. In fact, it is the simple situation that we talked about in Cournot games, and this particular equilibrium 3-3 is nothing but the old Cournot equilibrium. For that reason, sometimes the Nash equilibrium is also called the Cournot-Nash equilibrium. So, this shows you how game theory can be used to validate the equilibrium outcomes or equilibrium strategies we derived when we talked about the Cournot competition.